Easter Island, remote and mysterious, has fascinated scientists ever since it was discovered by a Dutch explorer by the name of Roggeveen on Easter Sunday in 1722. Known best for its statues carved by a civilization now extinct, the search for answers to its mysteries continues to this day. Who made these statues, and how did they carve, move, and erect gigantic monuments, some of them weighing up to 100 tons? When did they do it, and why? These are just a few of the questions that make up the Easter Island puzzle. Located in the middle of the South Pacific, some 2,300 miles west of South America and about the same distance east of Tahiti, Easter Island rises abruptly from the sea. Pounded by the ocean on all sides, its rocky shoreline offers no sheltering port for seagoing ships. On only 64 square miles can be found the remains of a once complex culture, a civilization that developed in isolation. The natives of Easter Island, known as Rapa Nui, were master stonemasons. Without draft animals and with very few natural resources, including metals of any kind, they carved hundreds of gigantic statues and erected them on massive stone bases. They also produced hundreds of rock carvings and developed a written language that still hasn't been deciphered. And yet, they lived in thatched huts or caves. Most scientists believe Easter Island was first discovered and colonized by Polynesians sometime in the 4th century. By the 18th century, a population which grew from perhaps 30 to 40 original settlers now numbered over 15,000. Over time, they had gradually deforested their land and crowded many of their plants and animals to extinction. They saw their complex society gradually descend into social and political chaos, and even cannibalism. What caused their civilization to decline? Was it due entirely to overpopulation? Or could there have been other factors, such as a change in climate? Perhaps a prolonged El Niño could have caused severe rains or drought. These and other unanswered questions of Easter Island's history have drawn scientists and explorers from around the world for over 200 years. One of the first modern full-scale expeditions took place in 1955, led by Norwegian explorer Thor Heyerdahl. Heyerdahl came by ship with over 35 scientists and crew and stayed over 9 months. He and his team carried out extensive work in archaeology and anthropology, and he was awarded the same Explorers Club flag which he flew on his world-famous Kon-Tiki voyage in 1947. "42 years later, the Science Museum of Long Island formed a scientific interdisciplinary expedition and followed in Heyerdahl's footsteps. Their primary objectives were to find out what the island looked like before man arrived, and what led to the decline of its civilization. They were awarded the same flag carried by Heyerdahl and were co-led by a member of his 1955 expedition team, Dr. John Lorette.
This expedition actually involves an interdisciplinary team. It serves as a model. If we look at any environment, it's best to understand it from its origins, how it received its natural history, the vegetation and fauna, the fauna and flora, and then the effects and the colonization or the introduction of its people, and what happened to these people. So with the team we put together, we were able to study these various disciplines and look at the past to get a chronological sequence of the past.
Before an expedition can be launched, there is a good deal of research and planning that has to be done, such as forming the team and raising funds, and if possible, to conduct a pre-expedition fact-gathering visit to the site. With that in mind, expedition co-leaders John Lorette and Bob Hem traveled to Easter Island to survey archaeological sites and locate deep-water coral beds for the upcoming full-scale expedition. While there, they joined Heyerdahl to celebrate the launching of another expedition, led by a Spanish explorer, Quintin Munoz. Munoz had designed a reed boat on Easter Island made of totora reeds, which grow in the island's volcanic craters. Like Heyerdahl, Munoz was out to prove that early man from Western Polynesia or South America could have used reed boats to navigate and colonize Pacific islands, including Easter Island. All expeditions that include a variety of sciences involve crating and shipping a wide variety of equipment, including spare parts. Oceanographers and marine biologists brought in special drilling equipment to core and sample large deep-water coral. Geologists and paleontologists had to ship drilling equipment and platforms to probe the swampy beds of extinct volcanic craters, as well as craters filled with deep water. The expedition included scientists and conservationists from the United States National Park Service. They worked closely with scientists from Chile and the museum on Easter Island. Their goal was to help develop a long-range plan to preserve and protect the statues and other artifacts from further ecological damage caused by nature or by man. In addition to all of the scientific equipment, a two-place ultralight parachute plane was shipped in and assembled. The parachute plane was brought in to photograph and map the island's landscape and its monuments, and to look for archaeological sites not easily viewed from land. With the equipment unpacked, the expedition turned to the tasks at hand. First, to find out what the island looked like before man arrived, to construct a past history of plant life. At the lake inside the crater, a team of scientists and volunteers, headed by University of Alaska's paleobotanist Dr. Daniel Mann, drilled deep for evidence of past plant life.
We came here to the core because Easter Island is extremely isolated and occupies a very interesting position on the Earth's surface, out in the middle of the South Pacific. We knew from previous studies that had been done here on paleobotany that we had a very ancient record in some of these craters. So we've come back to recore some of the same lakes that were done, that were cored 15 years ago, and to use new techniques to analyze the same data.
The best place to look was in Easter Island's extinct volcanic craters, such as Ranakau. Volcanic craters act as catch basins, where seeds, pollen, and twigs, blown by the winds over thousands of years, collect and form layers of plant history.
Specifically, what we're looking for is a record of what plant life was here before humans arrived about 400 AD. We're here on top of this volcano because it's very hard to find lakes. The world is unfriendly to lakes. They tend to fill in with sediment. And volcanoes and craters like this one are unusual places because they're deep holes formed by explosions that create these big cavities, and they fill with water and then with a swamp. So we've come up to the top of the volcano simply because this is where the lakes are on an oceanic island like this. The techniques we're using are, it's a modified Livingston core, which is a standard sampling device for coring down through lake sediments or peats. And we've modified it somewhat, so we put little saw teeth in the end of the barrel, and we're able to saw back and forth and penetrate the very dense peats, which, peats are just compressed, partly decayed organic material. We're able to cut through it with a saw blade. And that's one reason we were able to go so deep yesterday. But in sediment that had turned back previous investigators, we went on another 5 meters. The deepest core we got yesterday was 52 feet. And we only stopped because, well, when you get down that deep, there's a danger you're going to lose the whole shooting match, and which is rather expensive because though the instruments are simple, they're all custom machines, so we're looking at maybe $10,000 worth of gear. And if we're down 50 feet and something breaks, we lose everything because you'll never get down there again. From the previous work that was done in Rana Arroyo, 50 feet should represent maybe 80,000 years of accumulation, which, to put that in perspective, that's a remarkable pile of organic material. If you went out in New England, the oldest lake sediments or bog sediments you'd find would be on the order of 12 to 14,000 years. So we're talking 8 to 10 times records that you commonly find in the Northern Hemisphere, in North America, for instance. So what do we do with the sediments when we bring them back? Well, you've seen some of our core boxes. It's hundreds of feet and hundreds of pounds of basically mud, but it's very valuable mud after all this work. We take them back to the lab. Most of the analysis will be done at the Lamont Dougherty laboratory of Dr. Dorothy Petit, who works for Columbia University and for NASA. And she's a specialist on paleobotany, and her particular specialty is identifying plant macrofossils.
Dan and the team, John Loret's team, brought back 3 major cores from Easter Island, from the craters. And what we want to do, well, you can take a look and see how organic these cores are. And in one of them, we think we've gotten past the Ice Age. One core is very long. The second core is not from the center of the crater, Raraku, but from closer to the edge. And we want to see if that is more sensitive to the changes on the landscape that happened during the time period we're interested in. And the third core is to look at changes that humans have lived through in more detail. So we're not looking at Ice Age scale changes. We're looking at changes over the last, maybe the last 1,000 years in a lot of detail.
75% of the Earth's surface is covered with ocean. And the type of paleo and environmental records we have from the world's oceans is much more limited than what we have on land. All right, so our terrestrial records are more diverse and often more detailed than what's available from the sea. So Easter Island is has unique potential because you can view it kind of like a shipborne weather station that's been anchored out here 2,000 miles from the coast of South America for 3 or 4 million years.
Just as volcanic craters were drilled to find a history of plant life, a dive team led by Dave Mucciarone, geology professor at Stanford University, set out to drill sample cores in large, deep-water corals called briny sapata, which surround the island. When analyzed, the cores should provide information on... The divers headed out to Cook's Point, about a mile from the shore. There, at a depth of about 65 feet, they found one of the largest briny sapata corals in the world. Coral acts as a tape recorder of weather over time. As coral grows, it produces growth rings similar to those of trees. Each foot of coral growth represents about 100 years. When analyzed, coral cores should provide a history of temperature, rainfall records, and other data, such as evidence of severe El Niño episodes in past centuries. Cores up to 6 feet long were collected, representing about 500 years of weather history.
What we will do then is take these coral cores, like the one I have here, bring it to Stanford University, and we will analyze the oxygen isotopes and trace elements to help reconstruct the temperature and perhaps the precipitation signature that may be here at Easter Island.
The coral cores not only provided a history of weather changes over past centuries, they also measured the increase of carbon dioxide released into the atmosphere. Many scientists believe the increased use of fossil fuel is causing an increase in global warming, better known as the hothouse effect. This is the research area of geologists Warren Beck and George Burr.
We're here to study the effect that man is having on the atmosphere and the known increase in CO2. And we're interested in how the ocean absorbs that CO2 as time goes on and at what rate it absorbs it. And Easter Island is of particular importance because of its proximity to the equatorial waveguide, where you have a lot of upwelling from the ocean. And our climate is strongly affected by the exchange between the ocean and the atmosphere. Corals act as a tape recorder. As they grow, they leave layers, and so we can identify individual years or even seasons. And they absorb the C14 that's in the surface ocean at that time. This, in turn, has exchanged with the atmosphere. So we'll take the corals, we'll slice them, and we'll identify individual years, and we'll make measurements to see how this C14 is varied through time.
El Nino has a strong moderating influence on how fast CO2 enters or leaves the ocean. When you have an El Nino, it actually enters the ocean faster than during a non-El Nino period, and vice versa. So we can see El Ninos in the coral, because when you have an El Nino, the radiocarbon concentration will go up, and when you have a La Nina period, which is the opposite polarity, the radiocarbon concentration will go down.
On Easter Island, you can't escape being awed by the giant statues called moai. The crater Ranariraku is where most of the statues were carved. They were then transported and erected throughout the island, mostly on the coastline. Some have been restored to their original sites, placed on top of massive stone bases called ahus. Others lie where they fell while being transported or were toppled during early civil wars. Still others lie where they were carved on the sides of the quarry or buried up to their necks in centuries of rubble at the bottom of the crater. How were they carved and why? And how were they moved and erected?
We are at Ranariraku, an volcano used by prehistoric Easter Islanders, has the quarry from where they produce most of the stone carving of this island. There are about 300 of these carvings still in situ. And among them, this beautiful specimen that we are seeing here, where you have the head and the body carved, and yet the back still attached with the keel to the mother rock. They use this kind of tool, which is a basalt, dense basalt, much harder than the volcanic tuff. Eventually, they will release this moai and be pulled out of this area and then placed on a ramp built with the debris of the work and with an inclination sufficient to let the moai slide down and yet control at the same time with the ropes. And eventually, that moai will stay resting at the foot of the hill. Down in that spot, more work will be done. Now, once the moai reach the bottom of the hill, with their back facing the slope, the ancient carver will complete the carving of that statue. And then they will be ready to be transported across the islands. Now, the problem is, and the question most people ask, is how they were transported. Here we are dealing with one single piece of stone carved into a monument that weighed over 50, 60, and even 90 tons. And yet they were taken from here and placed on many different areas around the island. Well, the oral tradition has its answer. They said that the Moai walk. And many of the colleagues, anthropologists and archaeologists, also have their own proposition as to how they were transported. Some will say they were standing and they will be tilted and pulled like moving refrigerators across this landscape. Others will suggest that this same vertical position, but using wood sledge and with rollings, they will be pulled until reach their final destinations. And there's also a proposition that the Moai were placed horizontal on a sledge using a bipod method. It will be pulled slowly, like walking, all the way to the Ajo. But how they were really transported, it still is not a totally solved question. Here we are on Ajo Tongariki, facing the plaza of this monument. This is an outdoor altar where the ceremony were performed normally in front of this area. These moais represent the ancestors, and we have the largest one ever placed on an Ajo, perhaps right in this spot. It is about 90 tons. And above, we see the hats. Now, how these hats were placed on the top is another mystery that we have not solved.
We may know a little more of the how and why of statue building, but can we find the answers to when? When were the statues carved?
It's not known exactly how old these Moai statues are. One reason for this is the conventional materials we use for radiocarbon dating, namely charcoal or wood, just aren't present in this environment. So we're trying to use a new technique to date the age of these statues. It's called in situ radiocarbon dating, and the way it works is once a fresh rock surface is exposed, such as when the natives carve these statues out of the quarry and they remove a portion of rock, then cosmic radiation actually produces tiny amounts of radiocarbon in the rock itself. And we can measure this, and by knowing the amount, we can find out how old this quarry is.
Not all of the scientists in the expedition look to the past. Many are concerned about what we can do today to protect the remnants of the past so they can be enjoyed by future generations. Blaine Cliver, best known for his work in the preservation of the Statue of Liberty, is at the foot of Rana Raraku to photograph a three-dimensional view of a fallen statue. The strings wrapped around the statue form intersection points that will create three-dimensional computer images through special fiduciaries contained in his camera. These baseline images can then be updated over the years to measure the continuing effects of erosion. Cliver photographed many statues and rock carvings and other monuments throughout the island. As part of the expedition's investment in future exploration, Dr. Richard Renier surveyed much of the island for future archaeological studies, including a famous site known as the Poiki Ditch.
Why is it important? Well, it has the earliest date on the island. It is a feature which is hard to explain. There have been many possible explanations for it. Some suggest it was a defensive trench to protect the fertile soils up on the Poiki Peninsula. Some suggest that they were a series of earth ovens the trench also features prominently in local stories, local history, local folklore. The story is one of the long-eared people and the short-eared people. The long-eared people were trying to get the short-eared people to clear off some lava rocks, and they refused to do so. And the long-eared people were going to use this trench to trap the short-eared people, but the short-eared people were able to fool them and get around the trench, and according to the story, they were able to kill and burn up all of the long-eared people in the trench. So this is an important cultural feature, and we're hoping that our work will provide a baseline map from which future researchers can work.
Using a global positioning system, Dr. Rainier got precise fixes on key terrestrial sites.
Let's see if our satellites are lined up right. Yeah, looks good.
The expedition surveyed much of the island from the land and from the air. They also had a team of divers led by Dr. Dennis Hubbard, who studied and surveyed the waters surrounding Easter Island.
I'm here working with the Park Service as part of the expedition team. Our role here is twofold. First, we're trying to understand the natural system around Easter Island and how it fits into the larger Pacific, and how the processes that are operating around the island are affecting primarily the coral reefs that are here.
Expedition members covered much of the island on foot, as well as in deep and shallow waters. The parachute plane enabled the expedition to see and photograph much that cannot be seen or is more dramatically viewed from the air. Thanks to the gracious support of Chile's Air Force, the plane was able to operate from Easter Island's airport, which includes an 11,000-foot runway built by the United States as an emergency strip for the space shuttle. The plane flew every day the weather permitted, and often when it didn't. Strong winds and rain were the biggest problems. Able to fly low and slow, it managed to capture major features of the island, some not easily seen from the ground, such as the old Moai Road. It was used in centuries past to drag the finished statues from Ranuraku to their final sites throughout the island. Flying over terrain where there were no roads and few paths, a large stone ramp was discovered, built perhaps by Rapa Nui people of the past. This posed the question, but for what purpose? The plane also allowed, literally, a bird's-eye view of the effects of erosion over the centuries. The Poiki Rise, a long-extinct volcano, was once planted and cultivated by the island's earliest inhabitants. Over time, the loss of trees, followed by rains, wind, and perhaps a series of prolonged drought, had stripped off the topsoil. Also observed was erosion caused by cattle and horses left to roam and graze on the ceremonial platforms and rock carvings. And then there was the sheer beauty of the monuments captured by the light of a setting sun. Ceremonial ahus with the exotic names of Akibi, Anakena, Mananua, Pangariki, and the ruins of Vinapu, where the similarities of the quality of the stonework resembles the work done by the Incas in South America. And a restoration in progress of a solitary moai at the edge of the town of Hangaroa called Ataranga. Scientists were always ready to talk about what they found fascinating about Easter Island.
It's been said before, and I think it's really the most interesting thing to me about Easter Island is Easter Island is an analog perhaps to what's happening on the Earth under human impacts today. And if we can understand some of the environmental changes and the interplay between environmental change, so climate change, and human land use practices, and human population, then maybe we can arrive at some understanding of what may be facing us over the next 100 years in terms of human-caused environmental change, the greenhouse effect, for instance, and what we're doing to the Earth.
The other interesting thing about Easter Island is that you have an island sitting out here, and it has a whole island biology, ecology, that's different from the mainland. How did these seeds get there? Were they all windblown? Were they waterborne in the first place? So we want to compare the vegetation on Easter Island with what was happening on Chile, to the east of it, and also to see what happens in terms of the cores with the stratigraphy, how the sediment is changing in the crater lakes as compared to the ocean cores nearby.
Easter Island is a mystery. It's an exciting place because there are fragments of a bold past which, with no written history and no real understanding of how the people who lived here lived and how the weather affected them. It's also a tiny dot in the Pacific Ocean. It's the most remote island anywhere, and the climate here is something you feel every day.
The most fascinating part? Well, it must be the remnants of the ancient culture that are here. They're mystifying and fascinating. The statues, how they move them, what they were here for. It's truly fascinating. So that's an added plus to being able to come here to do our coral research, to see and get involved with some of the archaeology that's going on here on Easter Island, to try to discover what the ancient Easter Island or Rapa Nui civilization was all about.
Beyond the quest for scientific results, expeditions are opportunities for friendships to be formed with people. In this case, the people of Easter Island, the Rapa Nui. The Easter Island custom is for expedition members to have a formal meeting with the elders of the various clans, along with the governor, mayor, and other leaders of the island community. This is particularly important if work involves archaeological digs in cultural and religious sites. The meetings are usually wrapped around a festive dinner or luau, where traditional foods of pork, chicken, sweet potatoes, squash, and bananas are cooked in a ground oven over hot stones. Expedition leaders pledge that the island's cultural antiquities, such as the statues and rock carvings, will be treated with respect. Traditional native dancing rounds out the evening. For the Rapa Nui people, the plain was an ever-present reminder of the ongoing expedition. The Chilean Air Force maintains a base on Easter Island, but it has no resident planes there. The commanding officer asked if members of the expedition could give a talk to the high school Air Force cadets and let them see the parachute plane close up. So the plane was driven under its own power down the road from the airport to the town of Hangaroa for a meeting with the students to tell them about the plane and its role in documenting the expedition. Flying low and slow over the island, day after day, the parachute plane flew a flag that carried a rock rubbing of a bird that represented the ancient religious cult of the Tanyata Manu, the Birdmen of Easter Island. The Birdman cult followed the end of the great era of statue building, sometime in the early 16th century. Its ceremonies were performed at a religious settlement on the edge of the volcanic crater Ranakau. On the ridge of the crater Ranakau was the ceremonial center of Orongo, the home of the Birdmen of a distant past. At a ceremony which was held once a year, representatives of the island's clans climbed down the steep crater cliff, swam over to the small island of Motunui to find the first egg of a bird called the sooty tern. The first to find the egg, swim back, and climb the cliff earned the right to rule this island until the next year. When the Europeans first discovered Easter Island, it was a bleak land with grasses so withered it was taken for a desert, a land devoid of trees. Today it is an island with trees, planted by man, with roadways and houses, an island no longer isolated. The culture is changing. The modern-day Rapa Nui has mostly intermarried with others from Chile or French Polynesia. There are now small hotels and restaurants, and many islanders own cars. Yet there is still an air of mystery when you spend time away from the town, among the awesome volcanic craters and the ever-present statues. It is fitting that this island was named Easter Island because Easter is a metaphor for hope, for rebirth.